Hello, Vancouver. We are ready to go.
Hey, Mr. Keshe.
With what?
Okay, that sounds good. Can we fade out on the music, please?
Yes, we are ready to go when you are.
Just get your video up there.
It's open. Who opened that? You open it. Okay, never open it, please. We forget they walk in. Close it. Close it. Close it. Yesterday, not yesterday, before, I came up to the room in the hotel and I was passing, I saw a door open.
We're live, Mr. Keshe, unless you...
I'm going to switch up.
Okay. So to let everybody know, this is the beginning of the Blueprint teachings for Wednesday, November 4th, 2015. This will be a continuation from the teachings from last week's Blueprint Teachings Week at the Keshe Foundation Spaceship Institute with Mr. Keshe. And looks like we're just about ready for to go here, I think. I hear some whispering in the background, so we must be just about there by now. Mr. Keshe.
Yes, good morning. We have a bad lighting. It's the images repeating themselves. Good morning to you. Good day to you. This is part of the Blueprint Day. We, as we promised, we come back till somebody will announce a result of what they achieved. But there seems to be some problems with some people understanding of the winding of the copper springs. I had to think a lot in how you lot are getting it all the other way around and wrong way around. And this morning we discussed it with our guys who understand these things, and then we spoke with the factory that understand these things, and it's a very easy solution to it. And I've asked Vince, and hopefully when I start explaining it, everything else, how to do the winding on the blueprint will be withdrawn, and this will become the replacement for it. That from now on, everybody knows when we talk about the winding, doesn't matter what terminology you use, we call it the winding of the coil for the power units, for gravitational magnetic unit. We started from now that they can record it and take it out. If you take a normal hand drill, this is the easiest way to do it. When you have a hand drill, you hold the drill in your hand, facing the direction where you want to put your attachment to it. On a normal hand drill, you have a forward and a backward. What it means, when you want to drill a hole, you press forward, you push in. If you want, for example, to screw into the wall with a hand screw, you push it forward. It goes clockwise, away from you. But they all have a button which you can reverse it, which means you try to take the screw out, which goes anti-clockwise or unwinding. Put your drill onto anti-clock, which is unwinding position. Put the bar which you want to produce, if you can open it, you should be able to open it. You put your bar in the drill, which you tighten it. You put your copper wire into the grooves, whatever way you can tighten it that it stays in the jaw of the drill. And once you've done that, you're all experts. I'm the most lousy guy with the hand drills and these things. Even I've done engineering, I always hate tools. So what do? You tighten your bar, your copper wire, and all you do, just switch it on. You start the first rotation with it as it goes. If I can clip it, this is a very fine, because we don't have a gauge 14 with us here in the center. What I'm going to do, I'm going to tighten it a couple of times that it has the body to be gripped. All you do, you turn the machine on and let it run away from you. And that's all you need to do. This is how you call it clockwise, anti-clockwise. That's how you make your spring, the coil. Very easy. You make it tighter as you like. You can make it open as you like. But now we've answered all the questions. How do you make it? If it's a right-hand screw or a left-hand clockwise, whatever. This is how it should be. This end is this end which is towards the machine where we started is your gravitational, or if it's your center core, is the input, and the other end is the output. As simple as this. So all this misunderstanding about the magnetical and gravitational is resolved. If you look at the wire, it looks as is clockwise, but it's actually winded anti-clockwise. It's as simple as doing it this way. So a lot of you who had problem with this, you see it, this is what it's called anti-clockwise, because when you look at it from the field coming out, you see the bend. It's the field flow. So the way we do it and the way it's been done is this way. Doesn't matter how you call it. The winding for the coils, you place it in your drill. If you have a screwdriver, other people who use screwdrivers, you hold your screwdriver and you turn backwards with your screwdriver. That's all it is. The turning of the coil of the beam is anti-clockwise, and that's what we're looking for. That's what is called anti-clockwise turning. You turn your screwdriver, or if you have a machine, you put it, you face the wire towards yourself, and the machine builds up to the numbers you need. So this is the coils, you call it whatever we've taken with this way. Any question about the winding is clockwise, anti-clockwise, out of the equation. So straightforward, put your bar, assemble or push your end of wire into it, and just turn the drill as you are going reverse. Yes. Yes. No, you have to understand the difference. There are two separate conditions. One is making the coil, and one is connecting the coil. There are two different sections. Yeah? The way you do the making of the coil has nothing to do with the way you connect them. So when you make two coils, one magnetical, one gravitational, your magnetical and gravitational both go through the same condition. You put one inside the other. When you connect it, when you make your loop, then you go by the principle of what you have, what you call your gravitational loop, and what you have in your magnetical loop. Yeah? So you connect because you have, this is one set. Then you have a bigger set which sits outside. We have the gravitational, and then you have a magnetical. So maybe let's do a different way to stop the confusion. I'm going to go backwards. Let's take this out. Let's take this out altogether. I don't know what's this. Okay. If we take this out, and we call this the inner ring gravitational magnetical, and then we call this one the outer ring magnetical. I take purple, and this is the gravitational, the magnetical of the outer ring. So if we call it 1, 2, 3, and 4. What do you do? Because don't forget with your magnetical, you have a slight difference in the coil, and that is you have turned this magnetical once inside itself only by a copper line. Yeah? And then you've done the same. You have turned this with, I choose another color, yellow. You have turned this inside itself by a second line. Yeah? This doesn't matter. So the way you connect is the gravitational here of the inner ring because it is in a clockwise. You go to the gravitational ring of this one, you connect here. So you go from two gravitational, the inner gravitational to the outside gravitational. Oh, sorry, yeah, you're right. No, it's correct. Don't tell me the outside, I'm right. Because this is, yeah, you're right, sorry. You connect, we put the yellow back on, the green, the yellow back up here. So you have the green, which is the beginning of it, end of this gravitational. We go to blue, which we chose that way. Then all the connections are in blue. Here you connect your gravitational end of this, and then it goes through. When it comes back, you have this here. Yeah. When it comes back, you go from gravitational end to the magnetical of this end. And then, because you go, no, it's a counterclockwise. You go, it's correct here. You go from there to here, and then you go from this here to here, and then you have your two ends. This end goes to your unit as magnetical, and you have this end of the red here, which is your negative gravitation. You connect your grid or the other tray to this point, the power goes around, it goes to the gravitational beginning of the other coil, it goes clockwise, it comes out, you connect it back to the inner center magnetical, anticlockwise, and then you connect it to the outside and you take your power from it. Don't forget, this is something some of you we repeat because we are in the process of explaining to make everything easier. When you make these coils, this is what is being said. Some of you might have heard, some of you might not. A lot of you know. We came with this with the situation with Sandor using a very tough copper. Is before you nanocoat, once you make your coils, this is what we're doing in the factory now, you heat up your copper wire ends, these ends. You heat them up just to below melting, that they soften. You bend them, you make all your connections with the wiring, and then you nanocoat. You've seen Richard doing it. A lot of people have a problem. We had this problem in the factory as well, where these are hard wires to work with. But once you anneal them, it's known as annealing, which is you heating to soften up. You do all your connections, you bend the ends, then you're safe with your work. So the process is very rapid, and as some of you know, you can make the 3-stacker, the 9-stacker, 6-stacker, or above. There is something I have to explain, or we got to announce, is that the units have already left the factory. The shipping has started. Please wait till at least end of next week. If you don't see your units by end of next week, we tell you the tracking number. We give you, because we don't want to cause problem for what I call the enemies of the foundation. The shipping has gone through a secure way. We hold the shipping tracking number for 7 days to make sure it has arrived. Our guaranteed delivery is 7 to 10 days, but we said 7 days should be enough. So the first batch of people, sometime today, tomorrow, early next week, should receive your units. Please, when you receive your units, as you have received it, inform us. I've received my one little email. Go back to the Keshe Foundation, where there is to do with the units, and just inform us I received my unit with a tracking number. This is important for us because there is a huge structure to set up. We are going for not only the power units, we are delivering from the same factory the pens, we are delivering the pads, we are delivering all sorts of things, something like 10 different components within the next few weeks will deliver the factory. So we need to get tracking back that we know our operation. And the only way it comes, not by them telling us we delivered it, don't say we never received it, is by you informing us. And if there is any problem, we open up a line called customers or whatever, they're going to announce it. Then you get the response back. We can tie up the ends. The car units are the first units which have left. The energy units are the second batch which is left. We had to modify things even in the last minute of the production to make sure everything is in order. The car units which you receive carry a very heavy duty cable. The ones you get for the battery operation. The connection is done inside the unit. What we've done is, I'm looking for a pen, and I forgot I don't use color pens anymore. So what you have two heavy-duty cables coming out where the connections have been made inside the box in the formation we should be. So when you receive it, go back on the foundation website about the connection. One goes to your whatever you want to connect it. These are plain cut wires. You have to strip them and put them where you want them. If you want it to be part of your battery, you want to have addition, put it somewhere else. So if I remember, it's a standard blue and brown cable. So you connect it. The cables are about 1.5 meters, I think, plus long, that you can find a position anywhere in the car for them. It doesn't tie you up to one place. You can put it in a boot and bring it forward. Everything has been foreseen that way. They are very high tension cables. So you decide where and how you do it. We advise you, if you don't understand about these things, go to a car mechanic and just say, connect these two ends, understand which end is which end. The manual should tell you that where you have to connect, what to wear, which one is positive, which one is negative. The color is explanatory international level. So when you receive units, I'm pretty sure some of you should receive it this morning because they've been shipped before. We kept silent, but some people should receive the first unit. If you receive it, please just go back on the foundation and inform the customer services you received your units. We know where it's going, the way it is. And all your energy units, we will fulfill all our commitments, whatever is being paid for and not cancelled, hopefully within the next 7 days maximum. But you have to tell us when you receive them. If there is any need for changes, we'll let you know. And as you understand, you're part of a developing technology. We work together to find the solutions in different ways. There are possibilities, as I said. We have developed a new battery operation. We will market the battery operation. It will fit more or less. We're trying to get it fitted more or less to a battery like this for 9 volt. And it will last, we don't know, a few years. Does not need recharging, and it will recharge itself automatically, continuously. It doesn't need a breathing space of a day or two or a few hours to recharge because it works totally different way. It's a continuous production, and the 1.5 volt batteries should follow in the same manner. The energy supplies, as I explained yesterday, I was in a meeting with some industrialists in Rome, and the biggest concern they have, the industrialists, is what's going to happen to the structure of the economy of Italy with these units. This is the biggest concern. What is, and Italian government at the highest level are focusing on what we've done. It's a sword which cuts both ways. We are creating huge number of jobs in coming weeks as we are now going into mass production. But what I explained to the industrials and the government is very simple. We do not have a choice. We have a new energy system, fuel in the market. The only difference with this fuel is non-nuclear, and every man can produce it themselves. This is one of the biggest now we see here, because we are part of the structure. We had, as I explained, you had the oil, we had the coal. As we found coal, we used coal, we went to oil. Now we're going to solar, what do you call it, panels. Now, this is a new fuel. The governments and people have adapted themselves in how to use the new fuel. You could not get a, what do you call it, a coal and put it in your car and hope to drive with a coal. We tested it, we've done the, what do you call it, steam trains and the rest of it. We have, it's a position, it's a change of science. So we have to understand how we're going to adapt ourselves using these new technologies. I was even discussing it this morning and yesterday. We are developing new tools, new systems which uses plasma. So plasma heaters, plasma cookers, plasma everything else. Because one of the things, I think, Vince, you have to put this on the website regarding the Mavla system. You have to watch your washing machines. This is what we're looking at in the factory on Monday. Your washing machines, you have heating elements in it. Do not connect your washing machines to the line directly till after 2 or 3 weeks. Do not, be careful when you put your washing machines on. The microwave convection ovens. These are the things you don't try to keep out. After 2 or 3 weeks, slowly, when the power sets in, then start using them normally. Because most of the washing machines take cold water and boil it to the temperature it needs. It heats the water up. So you have a resistor inside. We are looking into providing a resisting system. We have seen it. It can be done. There's a possibility we can do it. As I explained to you, with the new adapters, which they sit like this. Yesterday, on Monday, we were looking at it in the factory. The first prototype should be on the table in the next couple of weeks. So where you have your, for example, Italian 3 plugs here, you have the normal 3 holes inside, and we build a system here that the 3 holes you have more or less sits on top of it, if you look at it that way. So it'll be a system like this. We show the prototype, the first prototype, in the next couple of weeks. That you take the adapter and you plug it in. This adapter, we think, at this moment of work, can allow a resistive unit, as we explained before, to be connected to the system. There is a guy who we hear has posted that he's managed to produce the system 5.4 kilowatt. Is the first confirmation independently, and we get other people who are now start building their system correctly. Will do the same, and we get it posted. The systems are in operation, and we have received a huge orders for delivery by the companies who are in energy industry. They have already checked. They are working with it. I was in a meeting with them in the past couple of days, and they want the system to be applied immediately in hospitals, because most of the system in hospitals are on a non-resistive, and one of the biggest expenses to run hospitals is electricity. Most of them are on what do you call saving light system, and the system can immediately, literally, bring all the major part of the expenses of the electricity in the hospitals, keeping the machinery which are non-resistive, and systems which are, what do you call it, the lighting system. So the first commercial order we received is to go to a number of hospitals to reduce the bill. The order was placed yesterday. I accepted the order, and so they are fully aware. They've studied it, and we'll see where we go to the next phase. The industrial application of the technology is huge. The saving on present use of oil and coal is going to be huge. Calculation, what was shown by the people who are looking into it, they are estimating a saving in the places where there is non-resistive, because what they looked at it, what they explained, is that the systems, like in Italy, you have most of the world the same. You have your plug system, which you plug in like the resistors, transistors, and the rest. You have a light circuit like in the hospitals, and then you have a system which is connected to heavy usage machinery like a heaters or what do you call it, the support section. What they see is these units can be connected to the line of the lighting and the plugs. And one of the biggest problem is guaranteeing the supply continuously, that if there is a shutdown, the system does not shut down. So we're going into the next phase of generation of the system, and we'll see what the next steps bring. So these units, the standard units, is going to be tested for these two, where they can isolate the heating elements. And by the time they use, what the idea is, by the time they use these systems, and we know the reverse coating of the capability of the system, they think this system will be nano coated in time, that they can use it in conjunction with all the systems. In next week, by the end of next week, as we promised to the Italian police force, we delivered the first car units to the Italian police force. Because again, it's part of the major expenses of any police force is a fuel cost. They cut from monitoring, they cut from policing, because they have to pay for the fuel. This way, with the systems, we pay for it to be installed with the police force here in Italy. I have met them, and what we'll do, we monitor the fuel consumption. Yes. You gotta wait. You need my microphone. Has it got still battery in it? Yes. You are. You can speak.
Okay, my question is about the nanocoating process of the coils. And may I draw on the...
Yes.
Cause
You're lucky you're here. Otherwise, you need a very long arm to get here from United States.
Okay, so I start from the drill.
Yeah.
This is my drill, and this is my coil. So the drill goes counterclockwise. So my coil starts, let's say, from here and goes like this. Okay, I have two coils. I have one, which is the bigger one, and one, which is the smaller one. We call it gravitational. Both are in the same direction. So, from my understanding, okay, let's say this is the in and this is the out. The in and the out.
Yeah.
Out. Okay, when I nanocoat these coils, so let's see here. This is the in.
Yeah.
And this is the out.
No, this is the out. This is the in, this is the out.
Okay, but I have these two.
Yeah, but that's the in of the magnetical, and that's the out of the magnetical.
Okay, so this part is the in of both.
Yeah.
And this part is the out of both.
Yeah.
But the direction changed, because in this coil I moved clockwise.
That's what, yes.
And this coil,
You
I
go.
move counterclockwise.
Yeah, that's the field movement, not yours.
That's the
That's
field.
the field. It's two different things.
Okay. So when I quote my
Yeah.
coil, in my understanding is I have to apply a voltage, millivolts, for to give direction.
You don't need to. You
So
just put it in a caustic and you can do it.
okay, because in my understanding, well, what I'm
Well-
doing at the moment is applying. Just because in my voltmeter, multimeter, the electrons move from the minus to the plus, I'm applying here the minus and here the plus
You're
and here the
current
minus
nanocoating, not GaNs nanocoating.
and here the plus.
No, you are GaNs coating or your your electric coating.
No, I'm coating with a caustic, but when
A
I
caustic.
make my coil dry,
No.
I apply
You
millivolts.
carry, you see, you carry the same proposition. Still minus, still plus.
Same.
The same.
Doesn't matter if in
No,
one coil
no,
the
no.
direction. Okay.
No. So you nano coat it the same way and you place it in the same way. When you're going to get your coil, is the flow which counts, not the matter.
Yes.
So if you change it, you create an opposition and then your system doesn't work. You have losses.
Wow.
You understand?
Okay.
So this in a way goes, if you do it that way, this goes this way, this goes that way, you create a obstruction in the field level. And then that drops your energy, that drops high. So this
Okay.
drops your energy level, high. Good morning. So, we have a more people here. Good morning. Hi. You are from Romania?
Yes.
You've been teaching yesterday or on Monday?
Yes.
Okay. Nice. Welcome. Welcome. Hello. Please sit down. Join us in the front. So you see the understanding. Good morning. The understanding is the connection where you create a flux flow. If you create an opposition, you create a clash, you create reduction, whatever, which one is stronger overtakes. So you're left with crumbs. Yeah, I don't know why nobody apply. We apply current in the factory in a way. What we do in the production is that we use 100-degree caustic. We keep the caustic constantly at 100 degrees, and we apply a very low current through the bars, through the coils, on a constant basis in the same flow, because we cannot wait to boil water or whatever. The production facility is set up. Don't forget, in a factory, you're targeting 100,000 units a day. This is a target in the next 2 or 3 months. So, and it's a new technology, so we are finding the parameters, new parameters. 10,000 units next week when it goes into, actually next week goes into production. Those 10,000 units should come. We're looking, because it's a commercial proposition, we are looking at 100 units per person per day. So everything has to be made so simple that it's just a production facility. Every 5 minutes, a unit should be out of the premises from the time. But don't forget, we look at every option. A new, this morning, I released, good morning, another color. Oh, they can't see it. There is a new capacitor setting which this morning it goes into the application, because when you have 4 capacitors, plasma capacitors in the circuit, you have all sorts of problems, especially when one of your ends of the capacitors is just a piece of wire, and then you have a coil. Yeah, so this wire has no connection anywhere, and it slides in and out. So we devised for a faster production starting from today. The units which go out, we've developed. I worked on it yesterday, and it's the easiest way. We just get a plastic cross. You've seen it, you use it in the, what do you call it, construction industry. You have these bars which are like a cross. They use it for tiling or whatever. And when you look at the tiles, all we do is we place the capacitors, 4 capacitors. So what you look at it is like this. Oh, sorry. What you look in your production, when you look at it, you see it. If you, I've never been good in drawing, but I should do it for you here this way. If you, this is a top view, you see 4 springs. The side view, you see this. You have 2 coils on either side and coils on the other side. So what we do, we connect the 4 coils up and the 4 coils down, and with one like heat resistance paper, you just encircle it. Your 4 springs, capacity unit stays the same, and what you have literally is like this. You have 4 units connected on top, you twist it, and 4 connected down, you twist it. These are your capacity units. You can put one parallel with your stacker, and you put one parallel with your entrance. So now we have a what do you call it? The capacity unit. 3-4 people can produce thousands a day. All you need to do is just put a tape connecting the top and the bottom. So this never moves out, and there is no possibility of a breakage. This is simple solutions we see, and because I know a lot of people are going into manufacturing, these are the things you have to watch to ease the production. Otherwise, you start making single capacitors, you try to tie them up to the other ends, and it moves, and if something happens, the pin comes out, you lose your capacitance. This way, everything, a capacitor unit, 4 capacitors, is a part of the mass production, because I know a lot of people are looking into go to production. You should know this makes life much easier to market the technology. It's a plastic. It doesn't matter. It's a nanomaterial. They're already insulated. It's just finding a facility to be able to be practical in production. At the moment, you have 4 capacitors lying next to each other like this, separated by material, and then the pin can move out. This doesn't allow any movement. It's one pack. It's a capacitor pack. So most probably in the next few weeks, we'll make caskets of 4 capacitors inside this production unit. And all we need to do is to make it in a way that it fits into the framework. Pardon? Yes, we try, but it's impossible. It's very difficult to do it. But it's got to be done, or we make the end as one band, because now they behave as one unit. Because it's this band at the end which connects to the stacker or to the power supply. There is something else. If you use thermal resistance units to stop the, what do you call it, the heating. If you have a heating in your system, you have the 2 lines from the grid. You use your phase line. You connect your phase line to your thermal resistor unit. It's a plug-in. You plug it in, and then on the other end of the thermal resistor, you use a normal wire and connect your, what do you call, the capacitors or your stacker unit at this point. You do all the matter state work before you come into the unit. Before you bring these, what do you call it, resistor units or capacitor units into operation here in parallel, you place your heat thermostats before the system. These are little things which help you very rapidly. As I said, we're targeting up to 10,000, 30,000 a day. So we are seeing it. The capacity, potential capacity in Italy is around about anything about 300 to 400 million in the next 12 months. We cannot meet it. We already asked other people to collaborate with us to increase the production. It's unlimited. If we achieve the battery units, if we achieve the new heating system using plasma, these all have to be manufactured in each nation. The job opportunity is huge. As I was explaining before we start, we've seen a positive move by the Italian government in supporting mass production, employment opportunities through new technology. This is what they've been waiting for. They were waiting for the first units to come out. And now that the first units are out, they're out with full force trying to support us to meet the demand of Italian market and international market for the time being. By us being ahead in production, in development, Italy becomes a leading supplier till the other nations come into operation. And we can keep that lead very much. And Keshe Foundation now is an Italian entity as a manufacturing organization, and we are answerable to the Italian nation, even though I control the majority shareholding on behalf of the Keshe Foundation in Italy. The whole concentration with wherever you work is to support your nations, to develop these technologies. Doesn't matter if United States, China, or wherever, share knowledge with us the way we do. Little nitty connections which improves the system, increases the production. Anything you see on one hand or other has to be applied very rapidly. The problem is not in developing the technology anymore. The problem is how fast we can commercialize it. And today, even though we now employ number of people in in Italy now in the factory, we announced today in the Italian website, only when we do the clear checking, we are looking between at least 3 to 10 people who know, understand how to make nanomaterial, how to make industrial scale in the factory. We want you to be, we employ you. The wage has been set between the agreement between the Keshe Foundation and Italian government between 35,000 and 50,000 wages per annum. This is official, we announced it today. If you're Italian, you've got to be Italian, not to live in Italy. You got to be Italian citizen, Italian, workforce, Italian person, because each nation will support itself. If you've been around Italian Keshe Foundation, we are looking for up to 10 people who can teach our present Italian workforce to understand the work, how nanomaterial it is, what is different than a matter, because in production now we see this gap. They don't understand the principle. We need you to work as a full-time with I think 35,000, 50,000 is not a bad wage. Don't forget you pay taxes, you're out of the frame of the donation system of the Keshe Foundation. And we already employ, so I was discussing with Vince this morning before I come in, that we are going to put a section, the workforce we need for Italy. So you can check in for job opportunities, how you can work with us. We are looking for Italian researchers here in Italy, and I'm sure the German manufacturing side of the Keshe Foundation will go into operation before end of this week to start recruiting or whatever they do to start their operation. They most probably go into production by Christmas or before Christmas. And the same is with the British and the Americans will be done in the coming days. So, as I said, now we become a workforce in Italy, and it has to be the same. If you learn something, share with us. We learn something, we share with you openly. One of the points which will come in the coming days is the production of the second unit of the unit, which I was told don't announce it, but we already told you we are working on a generator unit. The generator unit to be added to this present power unit will employ another 3,000 to 5,000 people in Italy. It's massive because then it changes a lot of things. Then the other point, which is we're looking for the workforce, is on the health side and what you call the food unit. These go all after Christmas. We don't have the time for it. But the power production, the energy unit, is the full production capabilities. We have grown so much that in the way we see it, the Italian authorities see it, they are moving us from one factory to another the next couple of weeks to be able to meet the demand of Italian nation. It's so advanced. The Italian government and authorities are embracing the new technology. We moved to a new location, and I was told yesterday negotiations are to move us to a more advanced, that we can employ a large number of people more in the center of Italy than where we were on the boundaries. So we have received a full cooperation, and if you're setting up the Keshe Foundation, you can ask for our units. We give you your units. You can show to your authorities what it's going to do and what it is. And because it creates jobs, most of the nations will support you. Most of your governments will support you because you become a new generation of the employment groups by the back of your own technology. You have developed it collectively, and now you deserve to use it collectively. Are there any questions?
I'm sure there must be some questions in the chat here. We've got questions such as, does the nano coating have an effect on computers?
Not as far as we've seen. People have been using the systems in conjunction with their computers at home. No. Don't forget, the computers work on a DC, and plasma is DC, so it's within its operation. The only time you will see what we said, like in a resistive mode, is where you have to introduce the system very slowly to allow the heating elements to be nano-coated very slowly. Let me explain to you why you will have failure in resistive units. The failure, I explained this before, with the resistive units is that this is your what do you call the heating element, the bars, which is commonly used to heat. Your nano coating from your unit, your plasma coming, they start nano coating this. What it does, it starts nano coating, and then what you're going to get is this. The resistive power of the bar, when it's nano coated, we've seen this 7 or 8 years ago, is that the nano coating stays more or less cool. The more it gets nano coated, the cooler it gets, but the resistive inside gets hotter, and it has no way to release its energy. So what happened? Somewhere here, you get a meltdown. When you switch it off, if you nano coat it very finely, if you allow nano coating to happen, not rapidly, over time, what happens is that the nano coating should be able to allow to happen so slowly in these layers that even if the heater of the what you call the heating element melts, the nanomaterial cascades it. The only problem is left is how you transfer the heated element inside, the heat of it outside. This is where the problem with the resistive units will come. The nano coating of the system will run and cascade the copper wire. And your copper wires have a limit. And then because they cannot, due to the nano layering, because of its darkness or its blackness absorbing all the energy, not only you absorb the material energy this way, you absorb the energy coming out too. It's a blanketing. And your wire heats up and then it melts. But in melting in one point or the other, if the nano coating is done perfectly, then it allows the next process, which you think is the heat transfer, to take place because of the high volume of the heat. The next generation of the heating elements, which will come with the plasma, is very, very simple. We introduce heat transfer interaction between different layers. It's a totally different technology, and then this allows you to release the heat in the environment. What you do, if you are in research and you can support it, or you can look further into it, is very much like this. You got to look for a new development, and that development is very simple. You have to create we still have a bunch of people. It's a holiday time. Just 1 second, please. Excuse me. Yeah. 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 Yes, just about 11, 11:30. 11 o'clock. He has to go. He has to go from here. 11:30 you stop. It's okay. Yeah. What you got to look into develop, what is a part of the equipment technology development, has to be a system like this. You should find a system which, let's say, you nano coat or you create a gas plasma from, let's say, copper oxide plus aluminum oxide, and then you create another plasma condition of, let's say, aluminum oxide. The transfer of the plasma energy from one to another in interaction of the plasma here should lead to interaction of the magnetic gravitational field, exactly like the upper atmosphere and the sun. This heat release, if it can be used, then you create a new heating system. You should be able to create two types of plasmas, which is one weaker than the other, and in transportation from one to another in a gradient difference, somewhere here leads to this heating of the environment. It's the dynamism of it. It's a dynamic plasma. You can do possibility of using oscillation, two separate different kind of oscillation of the plasma that will never catch up and is constant, and the rate of oscillation changes the rate of heating. These are the new equipments which we have to look for. Maybe the way I see it, less than maybe 5 or 10 euro to produce a system. It's understanding the transportation of magnetic gravitational fields. The other system which you're looking for is plasma heaters for cooking. You use microwaves. Now you have to use a plasma at a given point to deliver the temperature for cooking. So what we are looking for is very much the same thing, but centralized to a point that it can release energy as a given point using plasma interaction. When we solve these two, maybe in the next few weeks or few months, then you introduce this as new plasma energy, which connects directly to your power units, and there is no possibilities of breakdown. At the moment, even when you use 5.4 kilowatt, you're talking in an electron vibration level. Now we have to go into the plasma vibration. And it's safe, it's a standard, it takes what it needs, and what you need to do, most probably the time of what you call cooking will come to a few seconds. Within a minute, anything you want to cook is cooked. Because you decide the strength of the plasma and understanding that even, let's say, if you're cooking beef itself in a state of gas, when you interfere with its plasma state, it opens up. The separation of the plasma of the gas of the meat makes it soft. That's why we eat it. So we instantaneously add plasma to the matter at the level we need. So cooking time, spending hours in the kitchen, becomes history. It's not a microwave, it's the plasma transformation. If you understand this work, that's what I said, there is so much still to be taught and a lot still to be developed. Hundreds of years of what man has achieved, developing different type of cooking, making things. Now, when we rethink about it, we understand the interaction of the plasma in electrical, in matter state, in the plasma state, we can do huge number of jobs. One of the things for the industrialist, if you're looking for melting, for example, in the furnaces, you don't need to do this anymore. Melting can be done, industrial melting in a large quantity can be done literally by creating, understanding the magnetic field structure of the lesser iron. You have iron ore, you know the temperature. You know the temperature is a confirmation of the strength of the gravitational magnetic field. You produce it the same way as you produce nanomaterials by the separation from matter. Now you create a molten condition. Total cost less than, I think, $1, $2, if you understand how you do it. The other thing is extraction. The new systems you have to work for, there are millions of you not there. You are waiting for the energy unit, it's in a plasma condition. As I said to you before, the unit has one thing, connects to the grid, and the other end is a power supply in a plasma state. It's you who's changing it to the electron vibration to heat up or run your computer. If you start changing the state of mind in using the power of the plasma, then you see the opportunities changes. The lighting system, the electronic system, the extraction units, what you use, do we need to dig so much deep in the mines to extract copper? Not really, because now that we understand the strength of this plasma and we can dictate its strength, all you need to do, you need to create continuous gravitational magnetic field of the copper. And what happens? Anywhere on the ground, there is atomic or molecular copper, it gets attracted. We've done this test. This test was done about 4 years ago. It works. It's just industrializing it. You have the same thing as a poison. You find the gravitational magnetic field of the poison, and all you need to do, you make a copy of it, and it's extracted. The burning, the melting, the extraction by different means is totally finished. Once we start developing these technologies, it's so much to do. As I said, the greatest problem for human race was to discover a technology where it works the way the universe works. That's your biggest problem. In a paper I've written somewhere, I cannot find it, I was looking for it if I can remember where it is, something which explains the origin of the heating of the planet. How Earth is part of the book number 4. How you create the heating. Why the heating is only surface deep on the layer. The reason for this is important if you people understand who work with the heating elements, because part of the division of the Keshe Foundation, the organization we work with, they are only in heating emergency heaters for the homes. That's one of the reasons we merged the companies, was that they were looking for a free energy for their new energy heaters, and we could understand the other way. But to understand how do you create heat, why the heat is only a few meters from this planet. We saw this in a very simple way. If you look at the Earth creates gravitational magnetic field in a plasma state. The environment around the Earth is the plasma state too, our atmosphere. Where does the heating come from? The heating comes only by at the point of the matter state, just on the surface. The heating inside the Earth is due to this process. It's two different heating. The heating inside the Earth is due to interaction of gravitational magnetic field forces, which in interaction of different plasmas, what we call lava, and the central field materials create the heating. But the heating on the surface of the Earth and all the planets, where here is your solid state, just a tiny surface, is at a point where gravitational magnetic field of the center in the interaction with the gravitational field of the atmosphere with the separation of the matter state which creates the heating. It's the Earth solid layer interaction which creates the heating. And nothing else. It's the plasma inside coming out in the interaction with the plasma, which is the atmospheric plasma, and at the point of the interface is where your heating takes place. The difference is so much that it needs, was it 10,000, 4,000, whatever meters for the heating to be at the temperature we can live at 5 or 10 or 20 degrees. Because the temperature inside, or what I call the magnetic field strength inside, does not change. So the surface doesn't change either here. The only thing changes is the strength of the plasma, which is the plasma of the sun. As it interacts, it decides if it's 100 degrees or 20 degrees or 50 degrees. You got to understand the difference. And if you understand this, it should be very easy for most of you to create a very simple system. A coil, nano-coated with a GaNs on it. Then add a matter state, like an aluminum foil, and then put another, what do you call it? Another coil outside it. If you get the ratio of the strength the right way, you made yourself a heating element. The problem is the GaNs state strength and how you do it. You've seen this operation with the beads with Alex. What have you done? You had the Can we get rid of this fly somehow? Where is Armin? Our expert catcher is not here today. You put the element inside, you put the GANs, you put the, what do you call it? You put the tissue paper, then you added the aluminum foil, and then you added your coil on two ends. If you look, without you understanding, you already are doing the same, but you're not getting the ratio right. If you get the ratio right, if you be able to create, understand what you're doing. This is this one here, this one here, the center one is the center of the earth. Here, the green is the plasma here, what we call magma. Here is one separation, aluminum foil outside is the layer of the earth, the solid layer of the earth. And all you do, you transfer the energy, you take the energy when you slow down. If you can design a system that at this point, you don't take the energy away, but at this point, in respect to create another atmosphere around it, that it releases heat, you have made a plasma system, heat system. It's very easy to make. It's just developing it that we can use it. But the only difference is, what we see in our research is when you're holding this in your hand or this in your hand, the atmosphere stays the same. The cups, the plates feel the same, but you feel the heat in your blood. You feel the warmth in your blood. People who hold these units in their hands, they tell you, I'm warm. Because the minute you hold with your fingers in your hand, the energy transfer to your hand is through gas state. Automatically your body feels warm. Then you can literally connect the wrist to your hand. I want to be at 20 degrees today, warm and nice. You walk around 20 degrees. We've seen this. It's not a theoretical. It's just extending the commercialization of it. The whole place can be at minus 50 degrees. You set your temperature to be at 25 degrees. You feel comfortable, you can do. Because now you transfer energy through gas of the blood and your body. Don't forget, a very near system to this, some 30, 40 years ago, was developed on a chemical process where you could crush the units. I remember the Iranian police force, night duties at the winter time were supplied with. In a very cold condition, they could crush these units and keep their hands in their pocket, and they were warmed. That was a chemical, they last 4 or 6 hours. This, if you understand how to do it, it lasts your lifetime. We wear a watch. Now we adjust the thermometer, what we want to feel, irrespective of what is outside. This is how you warm yourself in a space. There are no jackets, there are no clothes. You keep yourself warm, your blood condition in a flow, according to the plasma. You say, this is what you need to be able to live in a space. From now on, in these blueprints and all the teachings, we start looking for development of new equipment. There's no use coming up with a power supply where you have no energy, no application for it. We got to change the application, but understand what it brings. This, if you can do, but you have to understand this first, how the heating of the elements on this planet comes. Once you understand the heating process, is not by rays of the sun, but is by actual the solid state of the surface and the liquid, which allows the separation of the field strength between the two, which creates the heat on the surface. The internal cannot change. The external is the deposition of the sun to the earth. So you get heated up or not according to how much resistance is there. Why do we have hotter temperature on the center of the equator line? wireless on the north or the south pole in separate position. So now you understand more or less. And then if you understand this in a more extensive way, you understand one thing which you need in development. Why we have a landmass and water in a given ratio on this planet. Why do we have different ratios of a landmass and a water? 5:1, 7:1, depends on what you measure. Because the heating is so much that you need the cooling system, which is the water. Otherwise, the whole landmass would have melted. There is a reason, there is a ratio for why we carry so much liquid. If we don't carry liquid, the amount of energy which is released from the central mass is so much that it will create so much heat on the surface. It will be hundreds of degrees, not as we have it that we can live on it. The cooling system, the cooling system, which is the rapid conversion of the plasmas in a soft way, is the oceans. Without the oceans and open seas, this ratio of the transfer of the plasmatic gravitational magnetic field from the center to the outside is impossibilities. It comes to a meltdown. So what you got to look in the blueprints, in the development of new technologies, new tools, are these kind of things. The new heating system for a space. I don't teach you this just to create a cooker or a heating of element that you can use the technology. You're learning this, that in a space you can warm yourself with a simple system like a watch. Because you transfer plasmatic energy to blood. We've seen it. People who are developing technologies around the foundation for us in the background, the support team, when they pick up these units, they feel the temperature, the heat in their fingers. It's cool, but the blood is warm. They always reported they couldn't understand it. I had to explain to 2 or 3 of them in the past 2 or 3 weeks. Because the temperature here is created by the gravitational magnetic field, which comes at this point, and because it's plasmatic, when it touches your finger, it transfers to it. So it's plasmatically. You cannot take fair course from Earth to planet Zeus. You have to be able, when you understand this kind of heating system, how this system, because it runs through your blood, you're blue-blooded, you're British. So that's what they say they are, aren't they? If you're a true British, you're blue-blooded. And if you don't know the reason, I can explain it to you. Do you know why they call them blue-blooded? Let me finish this one. I'll tell you, blue-blood British. They can explain to you why. So what happened? The plasma transfer is through the circulation of the lymph and the blood, and so you warm up continuously. And by the ratio of the heating, the energy transfer is instantaneous. Because you're a vacuum, you are a superconductor. So you got to see what is to come. As I said, we don't want you to develop a technology or a system for your cooking pot. We are developing a technology without clothing in a space. You can warm up your blood that you don't freeze. There is no need to wear these funny costume astronaut suits to put hot water in it or cold water in it or pump in hot water when you go into the deep seas. You just these are not theories, these are now working units. It's just commercializing it. It's taking time because there is more important things to carry on. But if any of you can extend this knowledge, put it on the table, we tell you how we done it. We have achieved it through this combination. Please extend the knowledge, add it and come back to us, or don't be one of those who go to China and come back with everything hidden over the headache. So put the plasma system into operation, understand it, and use it. You've got to be able to transfer plasma energy. not heating energy of electron vibration. Now, I tell you 1 second, what true, they say the Queen of England is true English woman because she's blue-blooded. As you understand, as you know, English people were so backwards in everything, they didn't have arrows. And when the Vikings came to invade Britain, they had nothing. They had no intelligence of anything. So the only thing they had was a blue paint. They used to paint themselves blue and jump in front of the Vikings. Ah! And they never seen a person, they used to run away because it's like seeing a Martian. And then they said the true British are the ones who used to paint themselves blue, and that blue has gone into their blood. So that's why they call the true British are blue-blooded. They're the people who had no intelligence how to defend us. Color was the only thing they had. They didn't have intelligence to make an arrow to defend themselves. So now that's how you become a true British. So now you see what is needed. Extend the knowledge of development of application. The blueprint weeks will be for development of applications, new tools, new communication tools, infinity communication control lines. Remember, we gave you the coils. You have a double coil. You have a gravitational coil, and then you have a magnetical coil. You have another gravitational coil, and then you have a magnetical coil. Here in the power units, you stacked 2 of them on top of each other, 3 of them that way. In the stacker units, you have put your coils like this, and then you stack 3 of these on top of each other. Now, learn a new technology. This is a control of the plasma. The plasma can be controlled in an infinity loop. Marco has built the first one before Christmas, the unit we showed you. What do? You build these 2 coils, which you put inside each other, and then you build the second coil, which you put on top of it. This is, if I can go back, if I find it, the drawing of the coils. Can I go back here? Wait. Previous page. Yeah. The coils inside each other. A set of 2 over a set of 2. Now, learn the next technique. The next technique is a control of plasma. Control of plasma comes this way. Where is it? I lost my page. Okay. The next technique in your development of plasma